Okay, we're going to talk about polar coordinates this week. This is a piece of polar graph paper. On your homework, I'll use a more simplified version like this. It just won't have the angles marked on the outside like we're going to see on some of the notes. Anyways, this is how you're going to graph a polar coordinate. So remember, we're used to regular coordinates. Like if I give you the point -5, 0.2, 3. That would just go left 5, 0.2, up 3. That is actually in the same location as this dot over here. Okay, I'll show you that in just a minute how that's the same. Anyways, what this will mean is they'll give you the degree or a radian measurement. Okay, and if you look closely, this says 150 degrees. And it just means go kind of like 6 circles out. See if you just count going out. Let me zoom up a little bit. See, that's 150 degrees. 1, 2, 3, 4, 5, 6. And I put it up. Okay? Seems pretty easy to graph these, and it really is. Okay? So we're going to see a couple of examples. And then I'm going to go back to this and show you how that would be the exact same thing as that. Okay, so let's do a couple of examples. Again, they will give you a number and an angle, and the angle can be written as a radian or as a degree. Now, if you look at your unit circle, 2 pi over 3 is actually the exact same thing as 120 degrees. So those two problems are the exact same problem, really. So go to that degree mark, okay, this line here, and it just means go 2 dots out. That's it. Okay, down here. Now, remember we can have negative angles. Oh, actually, let's go back up to this. You remember on these angles, I could write them several different ways. So here I wrote them a couple of other ways. 120 degrees is really the same thing as 480 degrees. That would mean we went to like all the way around the circle and then back to 120. Negative 240 degrees is actually the same thing. That just means you went negative around to 120. 2 pi over 3, which is here. Imagine if I went all the way around the circle and then to it. Remember, that's like 8 pi over 3. Or if I went the negative direction, that'd be the same thing as negative 4 pi over 3. So all of these will really have the exact same dot, kind of the exact same location. Just be aware that we can graph it. We can give it as different points. Okay, here's our next example. So some of them they're going to give you will have negative angles. So negative pi over 6, you can actually look at your unit circle if that helps you. This is positive pi over 6. So negative pi over 6 would mean just go down here, okay, to that mark. So on our graph, that's really going to be down here, and then the third circle out, if you want to think of it that way. Now, anytime they give you a negative, they can give you a negative on the number or on the angle. You need to rewrite it as the positive version first. Okay, so this 3 would stay, and that negative pi over 6 is really 11 pi over 6. Okay, so that'll be the first part of your homework. There's actually kind of 2 parts to your homework, is to graph it and write it as the positive. And then I'll show you the second part of your homework in a little bit. Okay, so you'll need to do this if it's not already positive. No, this one up here was positive. Okay, and they also, when we say positive, they also have to be like reasonably small numbers. Like that one I showed you a minute ago. If they give it to you as an angle that's like 480 degrees, you have to name it as something that's just normal in one time around on the circle. Okay, now let's do an example. No, actually, I'm going to start on this one first. Let's do an example where the number is negative, but not the angle. So when that's the case, 3 pi over 4, again, keep your unit circle out. That's probably how you're going to do the majority of your homework. 3 pi over 4 is right here, halfway in between. Now, on the polar graphs, they only have the 30s and 60s marked. They don't really have the 45s, but we know it'd be right in the middle there. Okay? So if this just said positive 5, 3 pi over 4, we'd go out this middle, imagine there's a middle line there, and we'd go out 5 circles. I know there's not 5 circles on this one. On your homework, there are. Okay, I was just trying to use something that was a little larger to show for notes. So you would go out 5 circles. But if it's negative 5, So imagine you're on that line, you just go backwards. Okay, so again, here's the line for 3 pi over 4 if you wanted to imagine it. Sorry. But instead of going out 5, we're going to go back 5, which would be a dot about right there. Okay, see, this is kind of 3 lines. Imagine 4. There's the 5th one. Okay, now that's really not at 3 pi over 4. That's really, if you looked over here, 3 pi over 4 backwards of it would be 7 pi over 4. So the name of this coordinate, but using all positives, which is what we have to do, would be that, positive 5, 7 pi over 4. Okay, now when they're both negative, start with the negative angle. Negative 150 degrees is really around to there, okay, because positive 150 is there, negative 150 is there. And then again, if that said 4, then we just mark a dot out here somewhere. But since it's negative 4, once I go around negative, then I backtrack to there, about right there. Okay, again, negative 150, negative to here. You could also do negative 150 plus 360 and get 210 if that helps you. But then I'm on this line, but I'm going negative, so I'm backtracking, following that line out. So that's really at 430 degrees. And you can see that once it's graphed where that is, because we have to name it in the positive version. You can't have any negatives, and you can't have this angle being a big number, like over 360. Okay, a couple more examples. I know this video is kind of long, but I really need to show you several examples like this because you've never seen this before. All right, 7 pi over 6. Again, on your unit circle. 7 pi over 6 is right here at the 210 line. So this would just be like saying 1 on the 210 line. That's easy enough. And we don't need to rename that because it's positive and this is a positive small angle. Okay, I'm going to try and do 2 on here. These are going to be the ones on your axes. So negative 3, 3 pi over 2. So 3 pi over 2 would be all the way around here to the 270. But if I'm going negative 3, I'm backtracking up like that. And that would be at the 3 pi over 2 mark. Okay? I know it says 90 degrees, but if they give it to you in radians, you have to give it in radians. Now, 2, negative 180 degrees. This is positive 180 degrees. It's also, if I go that way, negative 180 degrees. So then 2 on that. And it's the same thing. It's the only one that will ever be the same because 180 degrees and negative 180 degrees are in the same place. Now, by the way, I forgot to tell you that polar coordinates are actually used a lot in real life. If you imagine traveling like by planes and boats and stuff like that, these degrees would be like longitudinal, latitudinal, those kind of degrees. And they would tell a boat to travel like, you know, on this line for so many miles or clips or whatever they call it, you know, in boats and planes. So polar coordinates are actually used a lot in real life. Okay, I'm going to go back to this that I showed you at the very beginning. This is kind of like what part 2 of your homework is. These dots are actually in the exact same location. What you're going to do on your second part of your homework is, once you figure out where this dot would be located, you are converting it to rectangular. Now, this one's a decimal. We're not actually going to change ours to decimals. We're going to leave them with square roots and whole numbers and such like that. But 150 degrees, if you looked on your unit circle, those numbers, it's your x and your y, which are your rectangular coordinates, are negative square root of 3 over 2 and 1 over 2. So that's what, right there, the first circle, that would be the numbers for rectangular coordinates. But since there's a 6, you're multiplying all that by 6. So if you took that, change it to a decimal, multiply it by 6, you get something really close to negative 5.2. Okay, and then 1/2, obviously if you took that times 6, that'd be 3. And so that point is the same as that point, and you can almost see it too if you kind of look over. That's a little bit over 5 circles and go straight up. That lines up with our 3. Okay, So again, those are the same coordinates. So what you're going to be doing is getting a coordinate like this, using the numbers off the unit circle, multiplying by that number to get rectangular coordinates. But again, we're going to leave them as square roots. Okay, so again, this is the second part of your homework, switching that to rectangular coordinates. So 120 degrees, if you look at your unit circle, that's the numbers -1/2 and square root of 3/2. Okay, but this, you're going to multiply both of those by 2. Okay, multiplying those both by 2 would just basically cancel out the 2. So -1 square root of 3 would be your rectangular coordinates for that point right there. Okay, let's keep going. Now again, we already switched it from the negative to the positive. We know where it is graphed. So the numbers we're going to use are not the numbers from pi over 6. They're the numbers from 11 pi over 6. And those are right here. Square root of 3/2, -1/2. And then you multiply by that number. Now, up here, numbers like 2 and 4 and even numbers will cancel out that 2 on the bottom nicely. But if it's an odd number, it won't. So just kind of squish that together. So 3 square root of 3/2, and that would be -3/2. And that's your rectangular coordinate for that point. Okay, remember this one, -5, 3 pi over 4. So that was on this line, but we backtracked. So we really are using 7 pi over 4, those numbers. And if you look over here at 7 pi over 4, square root of 2/2, negative square root of 2/2, and we're going to multiply by 5. Okay, and again, because that's odd, it's not going to cancel. It's just going to stick a 5 basically in front of both of those. I apologize for my messy handwriting, guys. I'm trying to hold this paper down, and I'm writing with a big marker and trying to hold my phone for the video. So hopefully you get the idea. Okay, but again, on your homework, you'll have to show that. You'll have to show everything from the point. Actually, I'm going to give you, let me show you here in just a second what your homework will look like, but you'll have to rename it in the positive version. You'll select which point is correct on the graph, and then you're going to have to do this. Don't forget that part. Give the rectangular coordinates. Okay, by the way, the ones that have a 1 in front of them, you don't need to multiply by anything. I mean, multiplying by 1 doesn't do anything. And so whatever your answers are from 7 pi over 6, those just will be your answers. So like over here, 7 pi over 6, negative square root of 3/2, -1/2. That would be your answer. All right, let's look at these last two. And then I need to show you one other type. Okay, these are nice when they're on the x and the y axis, like the 0, 90, 180, 270. Okay, 3 pi over 2 is this dot right here. Now, think about that. That doesn't go left or right at all. All it does is go straight up 3. And if you looked at 90 degrees, that's your 0, 1. If you multiply that all by 3, that would just be 0, 3. That probably is the one that makes the most sense. Doesn't go left or right, just goes straight up 3. Okay, this one right here, again, without even looking at the numbers on your unit circle, it probably makes sense that they went left 2 and then they didn't go up or down. So the rectangular coordinates of that are just -2, 0. But if you did look up 180, you'd see it's -1, 0, and then multiply it by the 2. That would give you the right answer.